This is section 8.5. We're going to look at the mid-segment of a trapezoid. A mid-segment of a trapezoid is the segment that joins the midpoints of its legs. In this figure, segment MN is the mid-segment of trapezoid DEFG. All right, so the first thing we should probably point out, point M is definitely a midpoint because of the markings. Point N is definitely a midpoint because of the markings. You can't just say something's a midpoint because it looks like it. You got to have the markings. If the markings aren't there, then you really don't know, unless they're telling you it's definitely a mid-segment. If they're not telling you that, and you connect two midpoints, you can make a mid-segment. Okay, so notice how that mid-segment actually splits a trapezoid into two other trapezoids. Here's theorem 8.17. Here's two things we know about the mid-segment of a trapezoid. First thing is it's parallel to the bases. So that does guarantee that those other two little shapes that are created are trapezoids. Also, it has a length that's equal to half the sum of the lengths of the bases. It's just the average of the two. So we'll do something really simple here. We'll say that this guy is 5. That's how long that segment DE is. And then here's how long segment GF is. It's 15. What's the average of 5 and 15? It's really easy to do in your head. You know it's 10. But how do you average two numbers? Add them, then divide by 2. So 15 plus 5 is 20, divided by 2 is 10. So remember that mid-segment length is always the average of the lengths of the bases. Let's try an example. Find the length of mid-segment MN in trapezoid ABCD if A to B is 20 and D to C is 16. Okay, now we know segment MN is a mid-segment, so I'm going to take a second and make those markings just so I don't forget. How long is the green segment? Well, it's an average of the bases, the 16 and the 20. So I know that's 18. 18 is directly in between 16 and 20. If you're not sure, add them and divide by 2. Just make sure you add first before you divide by 2. 16 and 20 gives you 36. Half of that is 18. Okay, let's go backwards. So I'm going to erase these numbers here real quick for my lengths. I'm going to use the same picture. Find the length of segment DC in that same trapezoid if A to B is 15 and the length of mid-segment, segment MN, is 11. How would you find the distance from D to C? Well, I know the distance from D to C plus that other base that's 15. Averaged together has to give me 11. So I can solve that equation. Something plus 15 has to equal 22 if I multiply both sides by 2. D to C has to be 7 when I subtract. If that way makes sense to you, go with it. If it doesn't, let me point out an easier way. Let's pretend we didn't know that was 7. Now, you know the answer is 7, but let's just pretend. If your bottom base is 15 and your mid-segment is 11, do you see how that bottom base is 4 units longer than the mid-segment? The mid-segment has to be 4 units longer than that top base. So they're each a difference of 4. So 11 minus 4 is 7. Isn't that a lot easier?